Well, thank you very much for a kind introduction. I'm really thrilled to be here today to tell you about some of the wonderful experiences I've had over the last few years. Really chasing a giant, I think it's true. Driving up to the Mesa today, I haven't been in this room for 29 and a half years, almost to the day. And driving up today, I thought it's perfect that I'm ascending Mount Olympus to talk about one of the gods. Because it's really quite true that Sutcliffe had a huge influence on our field in synoptic-dynamic meteorology in particular. And I discovered this fact as I was putting together my series of notes for my very first class that I ever taught at the University of Wisconsin, which was our synoptic cyclone dynamics class in the fall of 1994. And I spent a good deal of the spring putting notes together and realized he really did have the franchise at one point in the field and invented it seemingly out of nothing. And I think the more I've learned about him over the last 3 years in this research project, the more I've solidified that opinion and not been dissuaded from it. I think one could make a seriously strong argument that the cornerstones of modern synoptic dynamic meteorology are threefold. One, the application of the quasi-geostrophic assumption to the equations of motion that not only simplifies them but also allows for the generation of physical insight. Adoption of pressure as the vertical coordinate. We'll visit with the height coordinate version of the thermal wind equation halfway through this presentation, and you will agree, if you've not seen it before, that it's horribly clunky and would have been impossible to manipulate in any reasonable fashion over a period of time. And then finally, development of a diagnostic equation for vertical air motion, which is, of course, a fundamental forecast variable, probably the fundamental forecast variable, because it determines the nature of the sky cover in such a significant way. And I think the argument that I will make today, and I continue to feel more strongly about it, is that, and this is in spite of the fact that there are quite a number of geniuses who have come along in the last half century or more, who have contributed to a lot of these advances that we've made in our science that are really quite remarkable, that have lifted our science to be able to say, I think, that numerical weather prediction, as one example of it, is probably one of the most unheralded inventions in science in the second half of the 20th century. And it didn't come out of nowhere. But I think Reginald Sutcliffe was the pioneer in all three of these fundamental revolutionary developments that have spurned the growth of our science to its current state. So I want to tell you a little bit about what I've learned about him in my 3 years of, it started with a sabbatical year, the first one I ever had at Wisconsin. It was in 2014-15. And what I've learned over the last 3 years as I've continued looking into his life. So my goal is to eventually, probably about 2 years from now, be done with a comprehensive cradle-to-grave biography of him. And hopefully that'll be available in about a 2-year time frame. It's been a lot of work, but I have really enjoyed it. It's been a life-changing journey, and I'll mention that more than once as we go through the rest of the talk. So Reggie Sutcliffe was born on Wednesday, I think it was a Wednesday, November 16th, 1904. And it was a rare, fair, and nearly windless day in North Wales. And here's the surface map from that day, and the red star indicates the town of Wrexham, North Wales, where Sutcliffe was born. I sent away to the meteorological office to get this, and they were happy to send it to me, almost for free, postage, I think. But you can tell, just looking at these maps, what a different state of affairs reigned in the early part of the 20th century in terms of even corralling the observations and making any physical sense of them. But that you get an idea what the surface map was. There was a barometer rising steadily axis to the northwest of Wales on that day. He was born in this home at 88 Bradley Road, Wrexham. The building still stands. It's right across the street from a beautiful Victorian era park, which was built, in fact, finished a year after he was brought home. And he ended up having a lifelong love of gardening. And people say this is canonical with the British, but that's, of course, nonsense. Not every person who comes from the United Kingdom likes to garden, but those who do are really vigorous about it. And Sutcliffe was one of those people. Many times later in his life, looking for properties when they had several moves to make, he and his family, it was always a factor in the decision was, what kind of a garden can I grow in the back? What can I do to the backyard? So this was a lifelong thing. And it was really quite interesting to walk by this home. Even his two daughters have never been there. They didn't know he was born in Wrexham. They didn't know any of this history. And so there I was more than once on the night and a half that I stayed, or a day and a half that I stayed in Wrexham, walking past this property, trying to conjure up the courage to knock on the door, but it looked as if it was not enthusiastically inhabited. And so I didn't actually cross that threshold. But this is the Sutcliffe family in the 1920s. Reggie's in the middle there. He was the third of the three remaining sons. They actually, Ormerod, his father, and Jesse, his mother, had four boys. The first one, William, died of diphtheria in 1906 when he was 4 years old, and Reggie was 2. His older brother was Robert, who later on developed some sort of an eye disease that kind of eliminated his possibility to go to school. But in the grammar school that they all went to, the teacher said Robert was the genius among the three. And then Reggie was born in 1904, as I said, and Alfred, his brother, was born 2 years later. He became first an army dentist and then had a successful practice in the southeast of England the rest of his life. So they were really successful people. And they came from modest means, actually less than modest means. Ormerod was the general manager of the co-op in Wrexham. And he had been in the co-op movement for a very long time after having spent most of his first 13, well, some large fraction of his first 13 years of life in factories in the central part of England. And it was a struggle for him to do business in Wales because he never really got a good handle on the Welsh language, which is among the most foreign of languages that I've ever heard. I've taken the train, into Wales on some of these trips, and at the train stations in Wales, the announcement about what train's coming and where it's going comes in Welsh first. And I'm telling you, my wife's from Vietnam, and that sounds foreign. But Welsh is even more so. I got to tell you, it's unbelievable how different it sounds from English. Ormerod could never get a handle on the Welsh language, and that forced him actually to pick up and move his business to somewhere else. So he ended up getting a job as the manager of the Cleckheaton in Yorkshire, the Cleckheaton co-op. So he stayed with the co-op, but they moved to Cleckheaton in 1907, and that's the town hall, which was built around 1880. And they pretty much moved into the same house just 100 miles further north, or further east, or west, I should say, east. And that was at 9 Prospect Terrace in Cleckheaton. It looks exactly the same. Again, I didn't have the courage to knock on this door either, but it was interesting to stand in front of it and imagine that this building was roughly the same, almost probably exactly the same as it was in 1907. And so that's where Sutcliffe grew up as a boy. Just down the street, to the end of Prospect Terrace, it makes a juncture with Whitcliffe Road. And Whitcliffe Road is a gentle upglide to the top of a hill, which has a fairly nice view of the surrounding area. And in around 1908, the community was at a crossroads about what they were going to do about education facilities. There were several grammar schools in the area, in the Spen Valley. Spen River goes through there, and it's called the Spen Valley. And there were several different grammar schools, and there was only enough money to make one of them improved and sort of modernized around 1908. And the decision to spend the resources in a certain location was controlled by municipal governments, not really by the citizens of any one of those communities. Not unlike what we have, I think, here. But the decision had been made around 1909 to spend the money to fix up the school in a local town called Heckmondwike, which is about a 6-mile commute from Cleckheaton. And this was not going to be it wasn't met with enthusiasm by residents of Cleckheaton, which was a sort of a cosmopolitan mix of industrialists as well as day laborers. So there was quite a nice, diverse population that lived in this relatively small town. And so they decided to build their own school and say the heck with the municipal authorities, and a group of industrialists and local townspeople who were not so wealthy joined forces to create this fantastic Whitcliffe Mount Grammar School, which was right at the end of Whitcliffe Road in Cleckheaton. It opened in 1910, but it was christened in controversy. As I said, there was a big battle in the town versus the municipal authorities in the region about what they could do. And the only way that this school ever came to be was by a really concerted effort by people who lived in that town, working class town with a few rich people. And they said, we are not going to have our children coming back and forth 12 miles a day. And this is just not modern. We can do better than that. And so they decided by subscription to raise the funds that would be required to build the school, something over £4,000 in 1910. It's a lot of money. And they did it. But they didn't do it without controversy. So there were back and forth between the so-called Cleckheaton conspirators, the people who had decided, especially the industrialists of influence, who had decided this is the path they were going to take in defiance of the municipal authorities and those municipal authorities themselves. And at a meeting at his own home on April 12, 1908, Reginald Grills, one of the conspirators, made a long speech which was published in the local newspaper, and I have a small portion of it here for you because I think it rings true today. perhaps more so this year than it would have 2 years ago. And certainly when I was first putting these ideas together and looking through the research, it was 2014-15 when our state in Wisconsin was under assault, the university was under assault by our governor. I couldn't resist. We live now under a democratic form of government, when everybody has a vote. And it stands to reason that if the power to rule is given to many, while the faculty of reason belongs to the few, that government is not a democracy at all, but government by the mob. If we want to have a perfect system of democratic government, we must have an enlightened people. And were that the only reason for a complete and universal system of education, that in itself would be sufficient to justify every effort that is being made in improving our education. So this was a really timeless statement made at a time when it was necessary to move the building of this school forward. And the school was built and opened in 1910. Sutcliffe began attending there in 1916 as a 12-year-old, what is that, third form in the United Kingdom or something like that. And he had a number of really important lifelong influences that he met in his, I guess it was 6 years of attendance at the Wycliffe Mount School. I don't have the names of all of the individuals on this page, but the headmaster's in the middle, Herbert Claiborne. He was a huge influence on Sutcliffe. You'll see him come back a couple of times. And his science master, his physics master, William Pearson, who will also make more than one reappearance in his history. This picture was taken in 1920. And for some reason, up here to the far left is Tor Bergeron's doppelganger. I don't know who this person is, but it looks just like Bergeron. You'll see a picture of Bergeron not far from now, and you'll agree. So quite remarkable. Reggie Sutcliffe was the head boy, which was the head male prefect in the school, which is a position of great honor, and that was for the last 2 years that he was there. He was a big man on campus. Here he is in the middle of a picture of his football team. He captained the football team this year, 1921-22, and he graduated that spring. So, he's got movie star good looks. We'll see him quarterbacking the Patriots this weekend, won't we? He looks a little bit like Tom Brady. But there he is. The team was 4-11 this year. They weren't a very successful team. He also captained the cricket teams. He was a big athlete. He was into all of that stuff at school. And he lived so close to the school that it was no problem for him to stay late and be involved in a bunch of different things. So he was quite a popular individual. This was a co-ed school too, so I'm sure he was popular with the girls as well. He was an athlete throughout his career at Wycliffe Mount. He won Senior Sports Awards in 1919 and another one in 1921. This is his Sports Champion Award in 1922 when he graduated. These kind of things one doesn't get one's hands on unless you make contact with the family. And Sutcliffe and his wife Evelyn had 2 daughters. And when I started my project, I had no idea who they were, what their names were they still alive. I had a librarian contact at the University of Reading who was helping me with some of this research, and she didn't know either. And so Hugh Davies, who I know, who knew Sutcliffe, he was hired at Reading in 1968. He didn't know if the daughters were still alive, but I found them during the course of this research, and what a thrilling moment it was to find them, and then to arrange visits and to actually see all of these artifacts that they've collected from their dear father, who's long departed. So it was really great to be let in to the family, in fact, welcomed. When I came to see them at different times, Jenny lives in Brittany in France, and Ellen lives in Norfolk in England. Both of them did their homework for me and had all sorts of things laid out on tables, and they were so eager for me to be there and learning and talking about their father, so it was really something. He graduated in 1922, and he won what's called a county major scholarship, and that allowed the county saw such promise in him as a student that they paid for his tuition at the University of Leeds, but they wouldn't be able to pay for boarding. Leeds used to be called Yorkshire College of Science, established in 1874. Beautiful place. I got to tour the campus and look around. He enrolled in September 1922, and Leeds was about 12 miles away from Cleckheaton. So this was a long commute. He still lived in Cleckheaton for the whole 3 years he was an undergraduate. So he was commuting every day to get back and forth. And that compromised his ability to take advantage of university life to the fullest. As you might imagine, he wasn't able to stay late and do the things that he had done as a high school student or the equivalent with the school just down the street. But he did get to swim, and this is a picture of him on the right there. Leeds University Swim Club in 1925, and these 2 guys here in the middle are brothers. I forget their names, but they kind of look like something out of an Al Capone's gang or something, don't they? I mean, they're just perfect. They look like 1920s gangsters. But he swam. for Leeds as an undergraduate, and he also became president of the Mathematics Club in 1925. And for the first time in his career, which wouldn't be the last, he got to give an after-dinner speech as a result of being president of the University Math Club. And he ended up being renowned for his after-dinner and other types of public presentations. So that was the first chance he got to do that. When he was done in 1922, or 1925, sorry, at Leeds, they asked him to stay and continue on a PhD in mathematics. And he was very disenchanted with what he had learned as an undergraduate in mathematics. It was not creative. It was a battery of tests and memorization and various things like this. He didn't really understand from his education what was underlying all of the insights that came from mathematics. And so he was quite disenchanted with the quality of what he had gotten there. But they couldn't afford to pay him a stipend, as is more common today, of course, when you go to graduate school. So he was in a quandary. How do I continue my education when I'm not funded? And again, you know, reminding you that his family was of modest means. And so Pearson and Claiborne, his headmaster and his physics master from Whitcliffe Mount, suggested, Reggie, don't forget, you won a county major scholarship to go to college. That means you didn't take advantage of any of the endowed funds that the founders of the Whitcliffe Mount School had put aside for educating people young people in the community. And so they encouraged him to apply, even though the circumstances were a little bit off the beaten path, for the Alfred Law Scholarship from the Whitcliffe Mount School. And the committee immediately said, yes, let's do this. We haven't had a PhD from Whitcliffe Mount yet. Let's make Sutcliffe the first one. So they were eager to pay for his tuition, but they couldn't pay for his board, so he didn't get to stay. Even as a PhD student, he had to keep coming back home every day to collect Heaton. So he started in September of 1925 under the guidance of Professor W.E.H. Berwick, who was a number theorist and an algebraist. And Sutcliffe hit him in his career at precisely the right time. Berwick had graduated 5 or 6 or 8 years earlier, I forget exactly, and he was reaching his peak of productivity and influence right at the fall of 1925. So Sutcliffe was, as I say, timed perfectly with Berwick's rise as a force to be reckoned with in mathematics in England. And so he started out working with Berwick. And he's really great quote that Sutcliffe has about his first encounter with Berwick as a student. And I think it really applies to all of us, whether we're still students or continuing to work in the field, because everybody goes through periods where they wonder, what should I do next? Where am I? You feel like you're a little bit listless, dead in the water. And Sutcliffe remembered in his autobiographical sketch, he said, I will always remember Berwick's introductory talk with me in which he relaxed my attention by saying, don't worry too much about your research at this stage. The important thing is to stop doing something. And boy, isn't that good advice. It's always good advice. So they had a very good working relationship and a reasonable personal relationship too, as far as can be recreated. But in about the early spring of 1926, so really the first year of Sutcliffe's PhD track, Berwick has been courted by University College of North Wales in Bangor. He started there as a lecturer before he came to Leeds, and they wanted him back because their department chair had quit. And they made him an offer, and he decided he was going to take that offer. And so he says, I underlined here in red, consequently, it will be necessary for me to resign my appointment at the University of Leeds to take effect on the 30th of September 1926. So here's young Reggie Sutcliffe, barely a year into his PhD, with his advisor about to move far away to North Wales, and he's wondering, what do I do next? And I have it in my notes, but I don't have it on my presentation. Several letters go back and forth between Sutcliffe and the registrar at Leeds about what do I do? You know, who should I contact? What's my plan? And finally, the registrar, in consultation with Berwick, said, why don't you just follow him up to Wales? And when you're done, you can get your degree from Leeds, but you can be doing the last bit of the work up in Wales, and that's what they ended up doing. So he moved up to Bangor, and this is the house he lived in, 35 Upper Garth Road. You can see a little bit of water down there in the far distance. That's the Strait of Menai that separates North Wales from the Isle of Anglesey. And right at the end of the street, there's several pubs, and they look like they're at least 70 years old. So it must have been a really nice place to live as a young graduate student, going down street to eat or drink with your friends and so on, and living fairly close to the campus as well. It's also the first time Sutcliffe ever lived away from home. So he was all going on 22 by the time he finally moved away from home. And so this must have been a period of great liberation and expansion of his interests and various other things that one can easily imagine. One of those interests quickly became this young lady named Evelyn Williams, who lived not far away in Wales and was a freshman or a first-year student studying languages at the same university. She was about 18 at the time and was interested in some local rugby tough guy. And I've got all this story from his daughter, so I'm not making it up. And Sutcliffe was interested right away because she's an attractive lady and apparently, as you'll see later on, a very free-spirited, progressive woman. So it was a perfect match for him, as it turns out. And so he was interested in her, but the interest was not reciprocated for quite some time. But he persisted, and that's one of the things that makes any of us succeed is persistence, and it certainly worked in this case. So after a while, she finally maybe either gave up or decided he's okay and started to find him interesting as well. And in June of 1927, he finished his PhD, so it really only took him a couple of years to do this. And look at the title. I would suggest I'm the only person in our community of atmospheric science who has ever seen the title and a copy of Sutcliffe's PhD thesis. So the title is this. I'm going to read it for you. Interpolation and tabulation of the numerical values of functions of a complex variable, comma, with a digression on certain subgroups of the modular group and the functions associated with them. What does that mean? I have no idea what that's even going to talk about. I can tell you this is a draft that his daughter Jenny had in her collection of artifacts. And it's something like 80 or 90 pages long and filled with hand-drawn illustrations of, sort of curves that might actually pertain in some way to this unknown subject. And anyway, it was really quite remarkable to be paging through Reggie Sutcliffe's PhD thesis. I didn't even know what it was. It was this long-standing story that he was a statistics major. That's not true. And it's so fun to see these long-held, even published preconceptions or errors about the history of a famous person evaporate before your eyes by something you're touching with your hands. It's really life-changing. So the reviews. These are some of the letters at the University of Leeds archives that pertain to his PhD. And these are the kind of arguments that people make to this very day. Look at the first sentence. In all this, there is neither much difficulty nor, in fact, much novelty. How many times have any of us heard that in a review? And we were talking about it just the other day, the ASP postdocs. I think you should never let that preconception or the sense that you might have, somebody might write that to keep you from putting something into the literature. Try anyway. And then fight them when they say this. If it's so novel, how come, or if it's so simple, how come no one else ever thought of it? Son of a gun, I hate that criticism. So the author goes on, he says, however, with a practical aim in view, and this is going to be a systematic thread through the Sutcliffe narrative, and you see it again later on, blah, 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 this leads to new formula connecting finite differences and so on, undoubtedly of practical value. So there's a sense that there's a practicality that underlies the approach Sutcliffe took even to his PhD, and you're going to see that repeated more than once. Berwick had the naive notion that this makes a useful addition to a theory. That might have not been naive, initiated by Klein, and here's the naive part, on which I hope Sutcliffe will work again. Sutcliffe never worked again in applied mathematics. Never. And so he parted ways with Berwick in June 1927, moved himself back to Cleckheaton just to collect, actually back to Leeds to collect some things and finish the paperwork. And while he was in the office doing that, despondent upon the fact that job opportunities were not plentiful in 1927 in England. It was 10 years after the end of World War I. They were still paying for the war. I mean, it was a severe depression on. So getting a PhD in math, as incredible as it sounds today, was not a path to a reasonable job. And so he was talking to somebody in the math department main office who was rather a primitive sort of placement officer, and she said to him, well, Reggie, I know, you're right, the jobs aren't all over the place, but you should call the meteorological office. They hire a lot of PhDs in math. And of course, the fundamental reason why they did is they were saying if you couldn't find a job as a mathematics PhD and no one was attracted to working at the meteorological office, it was a joke, you might still be able to say, well, I'm sort of a scientist, I can come and work for you. And so it was a last resort sort of situation. And he called and he got an interview, and he headed down to London for the first time in his life on the 5th of September 1927, interviewed for about 5 minutes. Everybody else was out of the office, he says. It was vacation time still, by soon-to-be Sir David Brunt, of Brunt Biseler frequency fame, later on president of the Royal Society, so a very famous person, of course. And Brunt probably had in his mind, of course, we'll hire a PhD in mathematics. There's not even any reason for you to come down, but let's go through the formality. And unless you're an utter disaster personally, we'll hire you. And of course, being the big man on campus several years earlier, this was not someone who was a disaster personally, and within 5 minutes he was given the job. Come back on the 30th of September 1927, which was a Friday, and why do you start somebody working on a Friday? But they did, just to show who's boss perhaps. Friday, September 30th, he started at the meteorological office. I forget what stop this is on the underground. I took it just last March, but anyway, it's the one that has the really long tunnel. You walk forever until finally you come up to the ground. Do you know which one it is, Hannah? South Kensington, that's what it is. It is South Kensington. And so this is now a science museum, but this used to be the headquarters of the Met Office, and Sutcliffe worked on the 3rd floor when he started there on Friday, the 30th of September, 1927. And he was immediately set to the task of doing work on the climatology of the most favorable air routes across the Mediterranean, because this was 5 years into Mussolini's fascist Italy, and Mussolini was, of course, dedicated to taking over the Mediterranean. That was his goal, stated goal. And the British had, of course, many possessions in the Mediterranean and many interests. And so they had to make sure they had their ducks in a row in case push came to shove with Mussolini. And so one of the aspects of that geopolitical strategy was to make sure you knew something about air routes across the Mediterranean to connect your interests. And he did that for about a year and didn't find that particularly interesting. He was quite disenchanted by the work that he was doing at the meteorological office. Imagine, you can easily imagine, it's probably a stack of flight reports in just paper form, and you have to somehow sort through each one at a time and try to make some sense of what all this means for aviation and preferred routes across various parts of the Mediterranean. I can't imagine a more boring job than that. Peter Hobbs gave me that task as a graduate student to look through radar displays from the Gale project. And I remember leaving his office after that was my assignment for my PhD. I want you to catalog all these rain bands and put them in a reasonable synoptic context. And I was working with John Locatelli as my main colleague at the time. And I came back in and my face was about as long as John Elway's, I guess. And he said, what's the matter? What happened with you in talking to Hobbs? And I said, well, he just told me he wants me to be an accountant. And I explained what I meant. And he said, don't worry about that. Do anything that's interesting. All he cares about is something that's interesting. And he was exactly right. Hobbs was great about that, so I had no problems. So after a year of boring work in the Met Office, uninspiring work, but he lived in London for a year, which he liked, he was given orders to go to Malta to further understand things about what's going on in the Mediterranean. So he moved there in late November 1928, and this was weeks after, there's Tor Bergeron, weeks after Tor Bergeron had been sent by Wilhelm Bjerknes to evangelize about the Norwegian model to the British Met Office. And they particularly said, let's get him down to the Mediterranean. Maybe, since it's bordering on subtropical, this is not a place where you can use the Norwegian ideas about weather forecasting and weather analysis. And so Bergeron had been the evangelist for the Norwegian model around the whole continent. In fact, his wife was from Moscow. He met her on one such trip. So he was down there from late October of 1928 for 6 months. And this was perfect shot of adrenaline for Sutcliffe to learn these analysis methods and to actually begin to believe that there was something scientific about meteorology. Of course, later on, he had views about the model that suggested to him that it didn't have any particular explanatory power, but it was still an interesting way to start thinking about the atmosphere in a way that up till then he had not been able to do. So there he was in Malta. Turned out to be a 4-year assignment. And in the following March, his not yet 21-year-old wife, Evelyn, comes down from North Wales. We don't know how. His daughters don't know how. There's no record of this trip. Maybe it was with a Navy wife or something that his parents knew, or her parents knew. 21 years old. Well, she was 21 in July, so she's still 20. This is a really big move for a young woman in the 1920s to come down by ship, by who knows what else, to get down to Malta, all by herself apparently, to marry Reggie. And that was on Tuesday, the 29th of March, 1929. There's their wedding photo. So they almost look like the people you put on the cake, don't they? Pretty incredible. And they were married in Sliema in Malta. And Sutcliffe was eager to start making research contributions. In the meteorological office at the time, research was officially discouraged. You couldn't do it from on your 8 to 5 workday, Monday through Friday. And yet, at the same time, if you somehow found time to do original research, and got the news out through the meteorological magazine or maybe through the weekly meetings that Met Office personnel had, it might have a chance to raise your profile. So it was a really perverse set of obstacles / anti-incentives that kind of flourished for a very long time, and you'll see part of Sutcliffe's career was actually the overturning of that somewhat perverse system. But he made some contributions that were minor at first and began to gain some momentum. He looked at what happens to your humidity measurements if you don't change the wick on the wet bulb thermometer most frequently enough. He looked at the importance of Atlantic ship observations for Mediterranean forecasting. Almost sounds like a data assimilation title now, doesn't it? I mean, you can almost imagine that. He was interested in the fluctuations of the barometer at Malta, rainfall at Malta, does it have anything to do with long period forecasting and so on, making all these contributions in the late 20s and early 30s. Then he gets back to the United Kingdom in 1932, and he's working for a while in the British Met Office, the center of it in London again for a couple of years. And they decide, the British Navy decides to deploy to Alexandria during the Abyssinian crisis, where Mussolini is saber-rattling about the Mediterranean, and his prime target at the time is Ethiopia as a demonstration of power. It's hard to imagine why, but so Sutcliffe is deployed to Alexandria in October 1935, and he's there for about 7 months or 6 months. And he almost forgot this. I got my hands on his handwritten autobiographical sketch that his daughter Jenny had in her possession among her artifacts. In fact, her sister Ellen in Norfolk said to me when I first met her, she said, "I think my sister says she has some autobiographical sketch that my father put together." And she said, "But don't trust it too much, because maybe she doesn't really know what she has. And she's never told me anything about what's in it, so she might not have ever read it." So I get down there in March of 2015, and amongst the items that are on the table for me, and again, I told you they did their homework, there's this just regular looking notebook that you'd buy at the drugstore. And I open it up, and there it is, sure enough, 81 pages handwritten of his autobiographical sketch. And he had handwriting, you'll see examples of it later, the handwriting of a grade school teacher. You can read it perfectly legibly. What a treasure. Nobody knew that existed, so I've transcribed that, and that's going to be at the end of my book, so that's going to be out there in the public, so I already have it done. So he goes to Abyssinia. Look at this. Ellen shows me in her collection of artifacts this beautiful rosewood Bible. And you open up the front page, and there's an inscription. It says, "To Ellen, from her daddy in Nazareth." A curious word that's next is "for," February 19th, 1936. And that didn't make any sense to me grammatically. And I'd already seen some examples of his command of the English language. I thought, this is not a mistake. This means something else. And I asked her, I said, "So why would he use that word? It sounds like a minute little detail," but she kind of caught on right away. And she said, "I don't really know. I don't even know why he was in Nazareth at that time. So at Christmas time in 1935. What was this all about?" So it wasn't until we found the autobiographical sketch that the pieces were finally put together many, many years after she had been thinking about this and without coming to a resolution. So this heirloom, which is beautiful, was explained by some foreigner getting involved in this biographical research, which was really great. Another one of those thrilling moments, you know, that you don't get in another way in our science anyway, but you get it in this kind of personal interaction with people. It was fascinating. So she was born the following February, and he knew that she was pregnant. His wife was pregnant with her at the time he was deployed to Abyssinia, or to Alexandria. So really interesting. In 1938, after he's brought back to the United Kingdom again, he's commissioned, or he's told, "We want you to do the pilot training, both for private pilots and Royal Air Force pilots. And they have to know something about meteorology." And Sutcliffe set about doing that. And for about a year, he was doing that at the Thorney Island Naval Squadron base, flying boat base. And he complained to the director of the meteorological office. He said, "You know, there's no textbook for this, and there's no clear syllabus." And he says, "I think that it would be easier to do this if there was some sort of textbook, so maybe you should start thinking about getting somebody to write that." And the director said, "You know, Reggie, you're exactly the person to do it. So why don't you write the textbook?" He said, "Well, okay, I'll do that." And then the director went further. He said, "You know, I think being in the office every day with all of the hubbub that goes on in our daily work, it's going to be hard for you to concentrate and put this thing together. We need to do it on the fast timeline, 6 months or so. Why don't you just take 6 months of the spring and summer of 1938 off to do this book?" And he said, "That sounds like a great idea." And they were both, you know, thrilled by this. And they went to the higher-ups, and it was such an excellent idea, the higher-ups, of course, shot it down. So, but they persisted, and that was actually the way it worked out. So he has this 2-year-old daughter wandering around the gardens with him in the afternoon. writing this book in the morning and in the evening, and having 6 months to finally, for the first time in his life, which don't forget, this was not a weather weenie. This guy didn't care about the weather as a young person. He was a mathematician by trade, forced into this job by circumstances. He finally got to read about meteorology and really spend his time tutoring himself, and then writes this fantastic book, and I'll say more about it just a little bit later. And he begins after this tutoring period that's initiated by the Commission for Writing Meteorology for Aviators to start making some substantial contributions in dynamics, and it starts to trickle out slowly. First with his colleague Charles Durst in 1938, the importance of vertical motion in the development of tropical revolving storms, a great title. This is only 80 years ago, okay, and it has that title. And it says the problem is discussed of the mechanism for eviction of air from tropical revolving storms by examination of the equations of motion, not by anything else. This is going to be a serious dynamic approach to this problem. So this is really interesting. Here's a statement that could be construed as synoptic gobbledygook, but at the end of this slide you'll see that it's not, so I'll read it for you slowly. If vertical motion occurs in the atmosphere in a region of horizontal temperature gradient, then ascending motion gives a component of wind from warm to cold, and then the converse, and descending motion, a component from cold to warm. It's hard to figure that out by words, and so they set about the analysis, and here's where it started. The ageostrophic wind is the vertical cross product of the acceleration vector. And you can expand the acceleration vector, the Lagrangian derivative, into a partial derivative, horizontal advective, and a vertical advective derivative. Durst and Sutcliffe attacked the vertical advective derivative in their analysis. So W times dV dz. That can be rewritten if you use the height coordinate form of the thermal wind equation as W over F divided by T, what a mess, times K cross D del T. And that arises if you assume the shear is geostrophic. They don't expressly do that and say, let's assume this shear is geostrophic, but let's take a practical approach to making hay out of this problem, is what they do. And so the next step is to just expand that, and you'll realize for a certain type of situation, which I'll illustrate on the side, I guess I'll do it right now, if I don't have any y direction temperature gradient, then I only have the j component of that expansion. And so the ageostrophic wind is the vertical cross product of this kind of weird looking function W over Ft times dt dx, which would be pointing in the positive j direction. And so the resultant ageostrophic wind is directed from the warm side of that bundle of isotopes to the cold side, where the yellow shading indicates there's upward vertical motion, as there might be in a hurricane around the eye. So you've got the temperature gradient, it's warm in the middle, you've got vertical motion around the eye, and that's going to give you an ageostrophic wind that evicts the air out of the center of the storm. So there's a lot of problems with this analysis. There's nothing close to geostrophic balance going on in that environment. But if you make that assumption, you can go from just listing your equations to actually articulating something about a potential physical mechanism. And that's really interesting. And it's the first time that it's been done. The next paper comes out. It's written by Sutcliffe himself on development in the field of barometric pressure. And he says, pressure changes are defined solely by the field of acceleration, and that is by dynamical considerations. So we can attack this problem dynamically. And the way he does it is he says, let's think about the vertical derivatives in the expansion of the acceleration term, the W times du dz and W dv dz. They have been neglected entirely except by Durst and Sutcliffe. Here's the full form of the height coordinate version of the thermal wind. So you have to take the derivative of the geostrophic wind in the y direction divided by t to get the expression on the right-hand side, and the similar thing for ug over t, and where t is absolute temperature. That's a horribly impossible expression to really feel like you can manipulate easily. So they have to make some assumptions, again, with a practical aim in view. Variations in absolute temperature with height are very small compared to the variations with the wind. So ddz of vg over t is effectively dvg dz. That's what they say. And we can get rid of the t, multiply it on the other side, and so we can reduce the quadratic on the right-hand side to something that looks a little bit more like a log function. So they have dug dz equals minus g over L, which is the Coriolis parameter, t, dt, dy, and so on. Then, this is remarkable. They've already done it, but they're going to say, if therefore the motion is quasi-geostrophic. This is the first English language invocation of quasi-geostrophy in this paper, and it's Sutcliffe, 1938. Then you can make some statements about how this will relate to the temperature contrast and so on. So Sutcliffe's the first person to make the formal assumption of quasi-geostrophy. He is not the first person to actually prove it as an asymptotic theory, right? That's Chani, who comes along later on and does that. Sutcliffe is much more interested, it seems, to value practicality over theoretical rigor or completeness at a number of different points in his career. But that's one method for stepping forward in the science. And he was a pioneer in doing that. It's really quite interesting. In 1939, Meteorology for Aviators is published by the Met Office, and in England, a year later in the United States. And the name Sutcliffe becomes synonymous with meteorology. RAF pilots all read this book. It was translated into French and translated into another language. It wasn't German, I know that particularly. I can't remember which one it was now. But it's almost certain that Luftwaffe pilots read this book, because they almost certainly knew English, or quite a large number of them did. So Sutcliffe became synonymous with meteorology. It really raised his profile. And he's also, at the time, as you can see, building a reputation as a forward-thinking, progressive-thinking, dynamic meteorologist. And then he has a really famous paper in 1939, Cyclonic and Anticyclonic Development, single-authored again. And this is the forerunner to the Sutcliffe development theorem, which is, in turn, the first omega equation. A criteria for development is that there should be a significant difference between lower and upper fields of divergence. So the next problem is, how do you take those different divergence fields, how do you analyze that? And he says, we're going to come up with rules concerning the distribution of surface divergence and convergence in different pressure and temperature distributions, and a method of approaching the problem of forecasting on a three-dimensional basis is put forward. Really interesting. Here's how he does it. Starts again with this really ubiquitous relationship. The vertical cross product of the acceleration gives you the geostrophic wind. If you divide the wind to consider two levels in a layer, if you divide the wind at the top into the surface wind plus the shear in between the two, and do some more manipulation, you can convince yourself that the difference between the acceleration at the top of the layer minus the acceleration at the bottom is forced by the imbalance of two terms. One of them is this weird tensor-looking thing, Vs dot del V naught, and the other is the rate of change of the shear vector. And so he takes apart this first term, expands it. First of all, you can use the scalar invariant operator to do that, and you get these four terms. And then if you think of a canonical picture like a surface cyclone sitting on top of a meridionally oriented bundle of isotopes, a bunch of terms that are in that four-term expression will drop away. There's no such thing, for instance, as U sub s, right? Because there's no y direction temperature gradient, and there's no such thing as dv naught dy. So there's only one term left, and that's Vs du naught dy times in the I direction. And if you take a look at these are surface winds in gray, that vector Vs dot del V naught in its simplified form will point in the negative x direction. Take the vertical cross product of that to get the net column divergence, or ageostrophic wind, I should say, and you'll get convergence of the net column ageostrophic wind, up shear of the cyclone, and net column divergence down shear. And this explains how the cyclone moves in the direction of the thermal wind. And if you put an anticyclone in there, you get exactly the opposite answer. And the anticyclone also moves in the direction of the thermal wind. Air is evacuated from this column, and the sea level pressure has to drop. Air is stuffed into this column, and it has to rise. And so that's why your cyclone's moving in that direction. This is dynamic. And these vertical motion couplets associated with the divergence downstream or down shear and the convergence up shear are aligned along the shear vector. And so I've termed them shear-wise couplets. There's a place in the literature where there's an intersection with that term. That's really dynamical and brand new in 1939. dvSdt. What if you assume the shear is geostrophic? It's going to be parallel to this bundle of isotopes. And if you somehow have a mechanism, let's say it's confluence, to push those isotopes closer together, the shear at that dot will increase. That will be your dvSdt, and it'll be in that direction. Take the vertical cross product of that, you get net column convergence on the cold side, net column divergence on the warm side. And not just at these individual locations, in strips on the cold or warm side. This is a transverse circulation around an active region of frontogenesis. And so when I saw this, putting my notes together all those years ago, this is the franchise. You have development and propagation of cyclones and vertical circulations at fronts all in one paper. Really quite an amazing achievement, and way before anybody else had seen these things. But 1939 didn't end well. The German army attacks Poland. Things go crazy after September 1st. Imagine what this must have been like, not only as a citizen of the United Kingdom, but secondarily, as your reputation is growing as the foremost dynamical meteorologist of the day. You're sort of like Ted Williams and Joe DiMaggio professionally. You're off to war at the height of your career. Very frustrating. but these people were heroes. They soldiered on. Ellen had this document that is the document saying that Sutcliffe was commissioned into the Royal Air Force Volunteer Reserve. Imagine this. Here it is. You can read the whole thing, but I won't. October 10th, 1939 is when his service began. And up in the upper right-hand corner, tenable for the duration of hostilities. Nobody, of course, knew how long that was going to be, but it wasn't going to be 6 months. So this was going to put a stoppage to it. All this great expansion of thinking, as well as put his family and his nation in peril. So Sutcliffe is, at the time, he's at the Thorney Island Flying Boat Squadron. He moves to Bomber Command headquarters in London, and then in November 1939, he's sent over to northern France in Arras. And he spends 6 months of the Phoney War in northern France. There's nothing going on at the front in the first 6 months of the war. That changes dramatically in early April. The Nazis take over Denmark, the Netherlands, and they move on Belgium and France, and the progress is rapid, so that Sutcliffe's evacuated from Boulogne back to Dover on the 23rd of May, 1940. So this was before Dunkirk. So he was out of there before Dunkirk. Before he left in late May, though, he had to run some various missions of reconnaissance of weather information or equipment and so on from places they'd left behind in Arras. And he did it at night with no lights on either a truck or a motorcycle. So these were harrowing events. This is somebody who was right in the middle of that kind of stuff. And he gets back to London, and they say, thank you for your service, but can you please go back to France? So they deploy him to Orleans, well south of Paris, out of harm's way for the time being. He lands there on the 5th of June, 1940, and then he drives down about 500 miles to Ceylon in southern France, where they are going to provide meteorological support for sorties that will be launched against the major industrial towns in northern Italy of Milan and Turin. And just as they're about to launch the first of these attacks, and this was going to go on as long as it was tenable, it was June 11th, the French all of a sudden completely change their course, and they say, no, we're not going to fly any offensive missions against Italy for reasons that are not easy to understand. I can't relate them to you. And so they got one set of flights off, and then after that, they were done, and they had to pack up, and all of this risk was wasted because of a lack of coordination between allies. And on June 18th, they evacuated from Marseille, and it's a long story that I'll have in the book about how this whole day, June 17th, 18th, went down. It was nothing but confusion and counter commands and counter orders and so on. They finally left Marseille on June 18th and headed to Gibraltar. There were no U-boats in the Mediterranean Sea at this point in the war, and so this was not a dangerous passage. This was relatively easy for them to do. But when they left Gibraltar and headed to Liverpool, June 24th, that was a different story, because June 1940 was a period of excessive losses of British shipping in Allied shipping in the Eastern Atlantic during the U-boats had their heyday at that time. So they got back to Liverpool by hook or by crook on July 1st, 1940. And I saw this next thing. This is the telegram that arrived at Evelyn Sutcliffe's sister's house in Oxford on the 1st of July, 1940. Just arrived, feeling grand, see you soon, love Reggie. Now that's easy to just kind of go over in the talk, but I want to just point something out. The capitulation was June 15th, 14th in France. The word on the street, according to the BBC, was by June 25th, all British service personnel who were not yet back from France were either captured or killed. So there was a whole week in this house in Oxford where Evelyn Sutcliffe was wondering, what the hell is happening to my husband? I am getting increasingly despondent about this, naturally. And her daughter's 4 years old. She even noticed a weight in the house. And she told me, this is 70 years after the fact, she told me that when that telegram arrived, she remembers her mother and her aunt hugging and crying and laughing in the vestibule of the house. And she said she could palpably feel a weight lifted off the shoulders of everybody who was residing there. That's amazing, isn't it? And there's the actual telegram that arrived that day. And there I am looking at it. Yeah, it's one of those moments, you know. You don't get those kind of moments too often. And you don't know when they're going to hit you, but this was really something. So when he got back, they didn't send him back behind enemy lines. They sent him to Exning in Newmarket, and he was the senior meteorological officer for No. 3 Group Bomber Command. There were 8 groups by the time of the end of the war. I think at the time he started, there were 6. And their biggest task was to be hitting industrial targets in Nazi-occupied France and also in Germany, especially Hamburg and places in the northern part of the country. And he was there for 3.5 years. So lots of other people had worse situations to endure in World War II. The Sutcliffe family was at least together for 3.5 years in their home country, and he was going back and forth to work every day, making forecasts for people to bomb fellow human beings. And he had nightmares the rest of his life about it, because there were many times when he'd send people out and the science was nowhere near what it is now, as you of course know, and conditions would deteriorate to a point that couldn't be foreseen in the 6 or 8 hours required for safely getting back, and many of the people they sent off did not come back. And he had lifelong nightmares from that. Never got over it. And the town of Exning was hit by a bomb. A stray Nazi pilot was there in February 1941, and this is the High Street. This is the day before Ellen's 5th birthday, and she had been promised some special toy by her parents, and her mother went into town that morning and said, "Sorry, honey, some of the storefronts were bombed out, and I couldn't do anything for you." So she told me that story. I thought, that's amazing. It's the only time there was anything ever dropped on their town. 28 people were killed, so it was really terrible. One of the main tasks that confronted Sutcliffe as the chief meteorological officer at No. 3 Bomber Group was forecasting upper-level winds, because when you take off and you're on your way to northern Germany, and then you've got to come back after you drop your ordnance, you've got to know what the winds are going to do for you, because you've got to figure out your fueling and all the rest of it. They had an abundance of surface observations, some of them sent to them in secret code by the resistance on the continent. So they knew how to draw sea level isobars. I've given you a schematic set here in blue. And by air mass techniques that I don't know, I think most people don't know anymore, that were prevalent at the time, you could actually make reasonable sense of the upper level temperatures based on knowing something about what air mass you were in. So there's a way actually to construct some proxy for a set of upper level isotopes. And then you could supplement that with the occasional radiosonde or flight level reports that came back from sorties that were coming back. So you'd have some idea what the temperature structure was at flight level. And that's indicated by the red isotherms. Well, then by graphical subtraction or addition, here are 4 different spots you might have real observations, you could construct a proxy for the 500 millibar geopotential height just by using the hypsometric equation. And it's based on this kind of analysis technique that you could make a statement about what the forecast level winds might be on the next round of sorties. This became easier if you adopted pressure as a vertical coordinate. And the Germans had experimented with this in the 30s, but not really done too much more than experiment with it. And Sutcliffe started to think, he had read some of this work, and he said, I want to really push this and see if we can't make this a daily routine way of looking at the data, because it makes the hypsometric equation and graphical addition and all these other things easier to do and quicker. And speed was of the essence, of course, in this problem. So that's where he started to think about that. Before he got to the point where he had really formalized his thinking, he was awarded this great award, actually, being mentioned in dispatches as a soldier or anybody in the service was a high-level reward. And he made this the first time September 24th, 1941. And here's the Order of the British Empire, which he received on January 1st, 1942. And there's Ellen, the little girl, and Evelyn standing behind her on the grounds outside of Buckingham Palace, waiting to go into the palace in July of 1942 to actually have that award conferred. So the introduction of isobaric coordinates. It's published in a meteorological office note in 1943, and it's by Sutcliffe. And they were doing this daily and making some sense of what was going on. He didn't take undue credit. He said, people have thought about this before, but we're trying to make this a daily routine. And then part 2 was using upper isobaric analysis to make forecasts of the upper isobaric contour charts. And that was done in collaboration with Otto Godard, a Belgian scientist who worked with Sutcliffe for a period of time in 1943. And they reconnected in Brussels later on as the war got toward its end. After he was summarily removed from Bomber Command in early 1944 because they wanted him to be somehow involved in their preparations for D-Day as a meteorological expert. So he was sent to the Bentley Prior Stanmore as the chief meteorological officer for the British. This was a horrible experience for him because everybody who was at this place was in uniform. And if you were, at the time, Royal Air Force Reserve, but you were on a domestic assignment, you had to come to work looking like me with a jacket and a tie, and you're surrounded by all these uniformed people, and there's a lot of macho that goes around amongst uniforms, and it was miserable for him. And he had no weather office there either, so he had no first-hand knowledge of what the observations were or the analyses. He was getting that by phone, so it was not a particularly productive time for him. That went all the way through D-Day. He was in on telephone conversations and changed the conversation on one of the critical days in early June where they were starting to think the 5th would not work. But it was not because he had hands-on experience or hands-on weather maps himself. After the invasion, he was deployed in late June to Granville in northern France. He didn't stay there long. He was on to Versailles in August of 1944, where he lived in a stable and was trying to figure out how he could contribute to weather operations as the front moved to the east. And then in October 1944, he was sent from Versailles to Brussels, and he was the chief meteorological officer for the 2nd Tactical Air Force, and that's where he reconnected with Goddard. And after October of 44, he went to Mönchengladbach after they had crossed the Rhine, and he made the official forecast for the crossing of the Rhine, the so-called Operation Varsity, which occurred in late March 1945. And here's a picture of him. That's Conyngham, the air officer in command of the British Royal Air Force, and a couple of other people. Ellen told me that this picture was staged. This was after the invasion had already been successful, so they made it look like they were pondering, universals, trying to figure out what to do next. And there's Sutcliffe. He made the forecast. But it was a beautiful anticyclonic conditions, not unlike what we had here today and yesterday, and so it wasn't a difficult forecast, he said. And then he went from Mönchengladbach to Bad Ilsen, where he was the head of the British Air Forces of Occupation from the end of the war until end of almost 1946. And so he was busy, or April of 1946, finally demobilized and back to England. When he was there, he was in charge of rebuilding the German Weather Service. The Allies were very smart at the end of World War II. In fact, in the middle of World War II, before the tide had even turned, they were planning for the peace. This seemed to me to be the ultimate jinx. It was like saying to your pitcher when he comes in from the 5th inning, hey, you got a no-hitter going. You don't do that, okay? But they were planning for the peace from 1942 on, late 1941. And part of that planning involved, they knew they were going to have to resurrect the German scientific infrastructure on all levels. And the meteorological part of that infrastructure was a major component of that. And Sutcliffe, in the British occupation zone, was given that job. And it was a substantial administrative job, and he accomplished it with aplomb. When he got back to England in 1946, there was suddenly 8,000 people in the British Met Office. There had started out with 800 in 1939, so it had grown by tenfold. There was no real idea of how we were going to reorganize the British Met Office at the time. And so he was a scientist without portfolio, if you will, and not really any obvious responsibility. So he took time to sit down and think about the things he had been considering but not able to fulfill with the pressures of his job during the war. And one of those things was, let's go back to this omega equation. And he sat down in early 1947 and started thinking about what turned out to be the development theorem. He started from exactly the same original proposition, but thought to himself, the left-hand side can be rearranged by a vector identity. You could think of that as minus the vertical cross product of the minus k dotted with the vertical cross product of the acceleration. And you can turn that into a vorticity equation instead. That might be easier to deal with than trying to figure out what does the acceleration vector look like. And that was really a genius move. Anders Pearson, who's a meteorological historian in Stockholm, insisted in the literature that this was a function of Sutcliffe having contact with Rossby in August of 1944. And Rossby, of course, was developing lots of ideas centered around vorticity. That is absolutely untrue, unfortunately for Pearson, but because he was in a stable in Versailles, and I've got documentation of that now. So Sutcliffe came up with this notion, perhaps by reading the literature, certainly, didn't think of it all on his own, but it was a creative leap to transform that expression into the vorticity equation. And then, again, as a matter of utility, the geostrophic version of the vorticity equation, retaining the divergence. And if you apply that expression to two different levels in a column, so it goes back to that drawing board, and subtract the expression from the bottom from the expression you get from the top, you get this really interesting picture. There's a difference in the divergence at the top of the column minus the divergence at the bottom. And that's forced by rearranging the vorticity at two levels, and it's also related to a Laplacian of the thickness tendency, as it turns out. And if you continue to rearrange that, you end up with this elegant expression recreated later by Kevin Trenberth in a different form, where the difference in the divergence in a given column is a function of the thermal wind advecting the geostrophic vorticity. And that is the Sutcliffe development theorem. And suddenly you've got an expression that tells you dynamically how you can assess vertical motion, knowing just the vorticity field and the thermal field. And why is that important? Well, here's an example from a case from some years ago. Here's the geostrophic vorticity sum, 500 plus 900 millibars plus F, with isentropes, column average isentropes, 1,000 to 500 and 900 millibars. And then the advection of the vorticity as a consequence of that, with the gray being the underlying vorticity. So you're going to have positive and negatives, red and blue respectively. When you invert that down here, you get the quasi-geostrophic omega. This is the actual full primitive equation model omega, and the values and the distribution are pretty darn similar in a lot of ways. So this is going to be a really powerful tool, and it's amenable to graphical use. And you don't have any other options in 1947. So this was a huge step forward for the science. And it started to generate prizes for Sutcliffe. He became really well known for this. He won the L.G. Groves Memorial Prize from the Met Office in 1951. Here's Rossby and Sutcliffe in Stockholm in 1952. Sutcliffe's development theorem was the blueprint for British NWP development, whereas Rossby, Chani, and von Neumann were thinking about the barotropic vorticity equation. Imagine just forecasting the vorticity at 500 millibars. That was a big enough challenge. And maybe Sutcliffe was too ambitious in saying, let's do 2 levels and let's think about a baroclinic model, at least something like a baroclinic model, right from the beginning. The consequence was the American efforts outran the British efforts for a while. And now some would argue things are about even or even tilted in the British favor, of course. We hear arguments like that. So there they are. They were good friends, strong rivals, but good friends. Sutcliffe was elected to the Royal Society in March 1957. So this is a big deal. And notice who signed it at the time. David Brunt, the same person who had interviewed him 30 years earlier at the Meteorological Office. Isn't that something? And this was heralded as the dawn of considering weather forecasting as a serious science, when finally the person who had spent most of his career as a weather forecaster, but as a dynamic meteorologist and researcher, had risen to this level. British meteorologists were suddenly considered real scientists. And Sutcliffe was, this happens only in the 3rd week of March every year, and there's 25 fellows elected. And so all the universities in England, maybe around the world, are looking in the list to see if they have any of their alumni who have recently been elected. And that was happening at Leeds as well, and so the registrar wrote to Sutcliffe and said, congratulations on your election, it's such a big deal for us at Leeds. And Sutcliffe wrote back, this is such a beautiful letter, I have to read it to you. Dear Sir Charles, the registrar, I am so glad that my election to the Royal Society has been noticed with pleasure at my university, and that you should have been so kind to write to me personally about it. Some of us cut away from our universities as we do from our parents, with gratitude unspoken, and never find the right occasion to express the warmth of our regard. Of course, we owe everything to them, and I would like through you to express a deep gratitude to Leeds after 30 years of enjoying the fruits of the trees there planted. With very many thanks, yours sincerely, R.C. Sutcliffe. Isn't that a beautiful letter? So, real command of the language and know how to express things. You could tell he felt things. In 1961, he was elevated to the 4th order of chivalry, 1 step shy of knighthood, but the most honorable order of the Bath by the Queen in her birthday awards in 1961. And there's the award itself, and here's Reggie, Evelyn, his daughter Ellen, who was pregnant with their first child, and her husband Dick, at the ceremony the following July, so it was later in the summer. And then in 1962, Prince Philip and the Queen came to visit the brand new meteorological office in Bracknell, and there's Sutcliffe pointing out the 500 millibar vorticity to Prince Philip on the 25th of June, 1962. Here he is meeting the Queen in the lobby, so this is a big deal. He had just met her a year before, and she conferred the award on him, so yeah, they were friends. But it turns out that, I didn't know this at the time, Director Sutton of the Met Office had noticed that Prince Philip was particularly interested in what was going on his 45-minute tour of the Met Office. And he actually wrote the Prince's secretary and said, bring him back if he wants to talk more about what we do here, and we won't have so much formality. And that never actually happened. So there must have been something about the interaction between Sutcliffe and the Duke of Edinburgh that day that was noteworthy. And then Sutcliffe was awarded the WMO Prize in 1963. This was a big deal. It was conferred upon him at Bracknell, and he went back to his old school, 1965, March 6, 1965. He gave what was known as the Pearson Lecture that day. He was the first person to do it twice. And this was Pearson, his physics master, and all the so-called old scholars had decided around 1945, we need to honor the influence this man has had on all of us. And we have an annual lecture where somebody comes, and Sutcliffe came and talked about predicting and controlling the weather. Imagine controlling the weather. Not just cloud seeding. Not just cloud seeding. This is 1965. So there's Sutcliffe. Every time he gave a public lecture, he had a globe. Every time. He demanded it. And there's Pearson, his beloved mentor. And this was the last day they ever saw each other. And he spent the night, I'm sure, that night. His brother Alfred was in attendance as well. He probably spent the night with Pearson. He knew it would be the last time he'd see him, and I'm sure they exchanged words. So that was something. It turns out the only day I ever visited the Wycliffe Mountain School was 50 years to the day from this day. It was March 6, 2015. The building itself was demolished this July, which is a great tragedy. And I did as much as I could to forestall that, but of course I had no influence. Sutcliffe resigned from the meteorological office. This is a story that I'm trying to piece together in exact detail right now. And after he came back from Wycliffe Mountain, he had found out just weeks before that the director at the time, O.G. Sutton, was going to be appointed as the first director of the National Environmental Research Council. And so he was certain to leave his post as Director General of the Meteorological Office. Sutcliffe was past 60 years old, and that's the required retirement age in the United Kingdom. He knew he probably was not in the running, but he didn't know who it was going to be. And so on somewhere between the end of March and early May, the decision was made at official high levels, and the decision was to bring in Sir Basil John Mason from Imperial College to be the next director of the Meteorological Office. It turns out there are so many things going on here. B.J. Mason was my PhD advisor's advisor. So I'm his academic grandson, and Sutcliffe stated in more than one place, I could not work for Mason. He liked him personally, but he couldn't work for him because he had a totally different outlook on how to push things. Mason was very much a go-getter and a sort of a in-your-face type personality, very different from Sutcliffe. And so he decided, and this is how I don't know how the decision came down and what the details were. He knew by July of 65 that he was not going to be at the Met Office after August 31st. I don't know anything more than that yet. But then he had been involved in discussions at the University of Reading when Reading had an impetus to expand its science offerings, as the whole collection of universities in the United Kingdom did at that time. And he and Sutton had been talking about getting a program started, although not with the intention of him taking the job. But somehow, when he knew it was going to be Mason as his potential new boss, he said, forget that. I've got to go back and talk to Reading. And they were happy to take him as the first professor. He founded the department at the University of Reading, which is now, of course, one of the most famous meteorological departments in the world. So that was his next assignment, 1965. Here's the Sutcliffe Lecture Theater in the current building that they use. And on the side of the door now, they have the same picture that I found in my research of him on the title slide of my presentation. They put it on one of those, when you take a piece of metal and you can kind of put the picture on there. It's there now. For the 50th anniversary of their founding of their department, they put that there. So I even have a hand in that. I felt really good about that. And that's the picture right there. So that's on the side of the Sutcliffe Lecture Theater. Someday I'll give this talk there. I don't know when. He wrote a popular science book, 1966. I got my hands on the contract because I got it through his daughter, Ellen. I said, the publisher said, you don't have probate, you can't see these things. I said, well, what if I get his wills? They said, that's a different story. So I got the wills and sent them in, and they said, okay, you can't ask us for this legally. You have to make Ellen ask us. That's no problem. Ellen, would you get these contracts? Sure. I got them last week, so it's great. I don't have any financial information, but they wanted the book earlier than it was published, so I don't know what the details are about where it came, what the delay came from. Great book. Look at this. They apologized to him in this next letter. They spelled his first name wrong on the cover. You will be shortly receiving an advanced copy of your American edition of the book. To anticipate the explosion that I envision when you see that your name is misspelled on the spine, blah, 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 I just want to let you know we're going to take all those books out of circulation. Not exactly. So there's one. And then in the same letter where they say, sorry for this horrible screw-up, hey, would you mind writing a textbook for university education? It's so sad for our field that he didn't do it. I think he would have been spectacularly successful. He didn't do it. Here are some of his medals from the war. And here's a picture of his family from Norfolk. So this is Ellen in December of 2014, her husband Dick, their son Lucy, her husband Nick, Sam and Rory and Sam, sorry. This is Ellen's daughter Harriet and her husband Dave. As I said, they were so gracious to me. Lucy and Nick had all sorts of remembrances of him and had letters from him. I think she was a particular favorite granddaughter of his, and so she had a whole bunch of letters that I got to share. That was really nice. And there's Jenny. Jenny was a fashion model in the 1960s in England, and her husband Jacques. They live on a big piece of land in northern France, which was really a great time. My wife was with me on this one. We had a great time on that trip. And then here is Sutcliffe's grave in Petrhalcon, Wales. That was Evelyn's hometown. And the first line of Shakespeare's Sonnet 33 is engraved on the stone. Full many a glorious morning have I seen. So this was really something for me to be standing there. And this was too early in this whole process for me to have the real weight of it hit me, but some of the weight hit me. There I was standing at his last resting place on a beautiful sunny day in Wales. It was quite spectacular. So I've got a lot more work to do, but I really appreciate your attention, and I'm happy to take any questions that you might have.